enough about it for today.
I saw them, they were doing sort of.
No. Huh?
Some of them.
No, actually they were doing quite well. In fact, they were doing better than this class.
Nah.
Yes, they were. They were. Quite pleased.
I told them how to solve a C.
Oh, this is why they're doing so well, huh?
We were when we were doing, we were like some 4 guys in the cafe.
Okay, that's fair enough. Alright, I shall do the homework first. What was first? The curve, was it?
Yeah.
Yeah? Right, so firstly, they ask, or I ask you to draw the circuit diagram. Yeah? So it's like this. Battery or cell, switch, ammeter, variable resistor, resistance, and finally voltmeter. Use the data below, draw the curve. Right. So my data was voltage, which is in volts, and current, which I gave you in milliamps. 10, and then 9, 8, 7, 6, 5, 4, 3, 2, 1. 500, 450, 400, 350, 300, 250, 200, 150, 150. So let's make the chart here. Insert chart, scatter, XY, next. Question 1, IV graph. Maybe I should say IV graph, question 1. On the x-axis is voltage in volts, and on the y-axis is current in milliamps. That's what you should have for the first question. So part C, is this material ohmic? Yes. Part D, include a row of resistance. Okay, so I'll go back over here. What is the formula for resistance? Yeah, V over I. So if I just include V over I. Now you have to be very careful though, because this I is in milliamps, not in amps. So I think what I'll do is I'll change the milliamps into amps. So how can I change milliamps into amps?
Multiplied by into power minus 10.
Yeah, multiply by 10 minus 3, which I'll do. So when I convert the milliamps to amps, and then do the division, I get this.
No. Oh.
You got 20 ohms? Yeah. Right, next is, what is the smallest and largest resistance? It's the same, it's 20 constant. What's wrong? You didn't get 20. Did you remember that these are milliamps? Grace, look up. So I should change these into amps. So that's 0.5, 0.45. Do you see this? V over I. V over I. Sorry, you can't see because of this. Is that okay? Right, lastly, what is the slope? So the way you can calculate the slope, can we look up please? Look up. Look up, look up. This is like the velocity time graphs we did. What did the slope represent on those graphs? Acceleration. So here, what's the height? What's the height? What's the height? What's the height?
500.
No.
0.5.
No. The height, what's the height? 450. It doesn't start at 0. It starts at 50. So the height is 450 and the base?
Is
9. So the slope is 450 milliamps divided by 9 volts, which is 0.450 amps divided by 9 volts. What's wrong? What is this number, please? It should be 0.05. 0.05 amps per volt. Do you remember what the formula for resistance is? No, from the graph, it's 1 over the slope, which is 1 over 0.05, which is 20. The same answer. Yeah? What's wrong? The first one. Oh, I didn't have to do this. Yeah, but I did it anyways. F, the answer is the resistance. This is like F. Okay. Can I do the next one? No? I don't want to actually, it's too nice. This is working fine. It is actually. It's nice and shiny, there's no scratches. I will take a picture of it. And I'll take a picture of me using it, happy. Playing some games on it. Right. Can I? No, not yet. Yeah? Yeah. Okay, so here, the next one, let me clean this up. So this is now current in amps. What the heck? Hang on. Current in amps. Delete. Delete. Alright, the first question. Let me type in the numbers. It goes 10, alright, so 21. Guys, look up please. 18, 15, 12, 9, 6, 4, 3, 2, 1. Now, that's question A.
That's not
No, it's not. B, calculate the resistance. Okay, so what's the formula for resistance? V over I. Now, what's happening here with the resistance? It's increasing.
Yeah.
Increasing to 1. Right. What is the smallest value? 0.476. What's the largest value? 1. And finally, is this material ohmic?
No.
No, it's not because there's not a straight line graph.